a KQED HD production.
In the 1967 film The Graduate, a college student, reluctantly approaching adulthood, was offered some prescient career advice.
I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics.
He was right. In the 1950s and 60s, the plastics industry not only transformed manufacturing around the world, it fundamentally altered the way people use and dispose of everyday products. Most plastic products are made from petrochemicals and are durable, lightweight, water-resistant, and inexpensive to produce. Worldwide, an estimated 330 million tons of plastic will be manufactured in 2010. That's more than 100 pounds of new plastic for every man, woman, and child on Earth. But in the United States, only 7% of plastic is recycled. Much of the rest ends up in landfills, where it could remain for more than 1,000 years. Other plastic is carelessly discarded, and it goes from stores to storm drains, streets to streams, eventually floating out to sea.
These persistent materials, if you wait until you see the problem, it can be too late, because once they're out there, they're very difficult to recover and can cause problems for many years.
Up to 80% of the plastic in the ocean comes from land-based sources. Once at sea, the floating garbage is caught up in the tides and currents. The currents that run along the California coast converge with 4 other prevailing currents from the far reaches of the Pacific Ocean. When they meet about 1,000 miles off the coast of California, they create a slow, swirling vortex known as the North Pacific Gyre. As the currents come together, they carry with them trash from around the world. On an expedition through the Gyre in 1997, Sea Captain Charles Moore of Long Beach was alarmed by the amount of trash, mostly plastic, that he found spread out over hundreds of miles.
This debris rides the currents of Japan. We see markings of Japanese and Chinese characters. Every single day for that week that we crossed these doldrums, we saw trash every time we came on deck. Bottle caps, shards of plastic, soap bottles, things that just didn't belong there, but were floating by.
Since that voyage, Moore has dedicated his life to studying the problem of marine debris and to bringing it to the world's attention.
We found in our lab analysis that the small bits of plastic outweighed the naturally occurring zooplankton 6-to-1 plastic to plankton. More trash than life.
Today, the Pacific Gyre is often referred to as the Great Pacific Garbage Patch.
Jimmy Hoffa's head!
With most of the plastic broken into tiny pieces, the garbage patch can't be seen from the air. Much of the debris floats a few feet below the surface. Scientists don't know its exact size, but some estimates place it at twice the size of Texas. Mary Crowley charters yachts out of Sausalito, California, and has spent nearly 40 years on the open ocean. After first learning about the garbage patch, she knew which direction to point her ship. In 2008, Crowley founded the Bay Area-based project Cassell, a nonprofit group established to study the scale of marine debris and its impacts on the environment.
Mid-ocean is kind of a beautifully unique area. You know, could be 1,800 feet, 2,000 feet deep. It's this beautiful blue, and then you look closer and you see this confetti-like plastic.
In August 2009, Crowley spearheaded a month-long scientific expedition to study the debris. The 151-foot Kaisei, whose name means ocean planet in Japanese, was joined by a second research vessel from the Scripps Institution of Oceanography in San Diego.
When we got out into the Gyre, we began doing bow watch, where we would record how many pieces of plastic the persons could count in half an hour. There were areas where we would see 300 to 400 pieces in half an hour.
Things in there right now. Might as well get them in there.
Marine biologist Margie Cassell works with the California Department of Toxic Substances Control, a state agency that regulates hazardous waste. Her specialty is the impact of contaminants on fish, but she wasn't ready for the impact the expedition would have on her.
The thing that was most shocking to us that we really didn't expect was all of the tiny fragments of broken down plastic. Every one of our samples had these plastic fragments in them, whether we were 200 miles from shore or 1,500 miles from shore.
Although petroleum-based plastic polymers never completely dissolve, over time, sunlight and wave action cause the plastic particles to break down. And because they are so widely dispersed, the billions of tiny plastic fragments in the ocean will be nearly impossible to clean up.
The amount of debris that we collected was pretty staggering. It was very depressing and very disturbing.
I don't like the jellyfish eating the plastic at all. That is going to cause our ecosystem real problems.
Plastic debris takes a tragic toll on marine life. Birds and fish ingest it when they mistake bright-colored pieces for food. Sea turtles and migrating birds can become entangled in abandoned plastic fishing nets known as ghost nets. Plastics also can leach chemicals.
We brought back over 300 fishes, particularly the lanternfish. We think that they're an important link in the food web. If they are in fact picking up contaminants, then those could be passed to the fish that consume them and potentially to humans.
The samples from Project Kaisei's maiden voyage are tested by the California Department of Toxic Substances Control. The samples are run through a mass spectrometer. It removes and separates toxic chemicals for analysis such as PCBs and BPA or bisphenol A, which are found in plastic and are known to be harmful to marine life and humans. As research is being done to analyze the problem, the search for alternatives is in the works.
So the plan is we're going to bring in methane.
At Stanford University, promising research is underway to develop an eco-friendly process for producing bioplastics that are benign by design.
It starts here with a landfill, anaerobic landfill. That's where you can produce biogas. We can use the biogas to help make bioplastic.
They're using bacteria that eat methane, a potent greenhouse gas, to produce plastic that is sustainable, biodegradable, and non-toxic.
And they store it inside their cells. Then we can break those cells open, extract the bioplastic inside the cells. The resin can be combined with fibers to make biocomposites.
I'm absolutely ecstatic at the progress we made recently, in particular, realizing that our bugs are producing plastic and we can probably use it for something useful.
Meanwhile, Bay Area cities are also taking action. San Francisco and San Jose have banned plastic shopping bags, and state regulators in 2009 passed new rules that require all Bay Area cities to do more to reduce trash going into the bay. Still, the size of the challenge is daunting, and any solution involves all of us.
I think it's on each one of us to make personal changes in our everyday use of products, and we can notify our representatives that we would like legislation to be passed to reduce the amount of packaging. The other thing that we can do is talk about the problem with our friends and family, because the more people know about it, the more chance there is for change.
The biggest threat to our ocean is ignorance. We are not in a situation where this can be done anymore. And we should use our brains to create things that are good for our own health and the health of the planet.